Hi guys, welcome to Nirmal's Code Tech. So now we're going to see the Padovan sequence coding part. So if you have not watched the logic part of this problem, please go and watch it so that you can get some idea how to solve this problem. And I'll also explain more clearly what's happening here in this problem. So let me move on to the coding part. So initially, what I'm going to do is I will check whether the value of n is equal to 0 or n is equal to 1 or n is equal to 2. The reason is in constraints they are going to give these kinds of input. So we need to check whether the 0, 1, 2 also should be considered as n. So in this case, I'm going to return the value as 1. So here you don't have any doubt. And after this, I'm going to create an array of size new int of n plus 1. So what's the reason for adding plus 1 in this array? For example, you take when n is equal to 3, you have the index value as 0, 1, and 2. So it will be allocated 3 size starting with index 0 to 2. But if n is equal to 3, you need to return the nth sequence, third sequence. So you don't have the value 3 to access in the array. So for that, that's why I'm added plus 1. And in that case, it will create a separate memory for the third index. Okay, now I'm going to iterate it for. So initially I'm going to keep the value I is equal to 3. The reason is that when n is equal to 0, 1, and 2, you directly will return the value as 1. So that's no problem. So surely when n is greater than 2, in that case only you are going to move on to the loop iteration. So now you are going to check whether I is less than or equal to n. Okay, I is less than or equal to n, no problem. Now what I'm going to do is I'm going to follow this process. P of 3 equal to P of 1 plus P of 0. Okay, array of I equal to array of I minus 2. When you subtract it from minus 2, so you can see here the formula P of n minus 2 plus P of n minus 3. So that's what I'm applying here, plus array of I minus 3. So in this case, what you'll get? An array of I minus 2 is nothing but array of 3 minus 2 is 1 plus array of 3 minus 3 is 3. So sorry, 0. So when you add these things, you get 2. So that will go and store in array of 3. Reason I is equal to 3. That's what I'm saying, array of 3. Okay, after this, when the value gets changed to 4, it will comes out of the loop. Reason is 4 is not less than or equal to n. So in the case, I'll return array of 3, sorry, array of n. So here the reason for returning array of n is that the n value is 3. So in third sequence, in third index, we have stored the value of array of n. Okay. So after this, let me check whether the program is running or not. See, I have used very simple small example. So that's why you get some bit confused. You can take n equal to 7 and you can check through this program. Surely your output will be right. Okay, I'll run it on. I got illegal start of expression. Okay, guys, I didn't put the semicolon here. Illegal start of expression. Okay, let me run. Okay, illegal start of expression. What is this? N is equal to 0, n is equal to 1, or oh, sorry, I wasted extra. Okay, your output 0, expected output is 2. See, I have not initialized the value of 0, 1, and 2 equal to 1. So that's why I got this error. So I'll try to initialize it. Okay, array of 0 equal to array of 1 equal to array of 2 equal to 1. Okay, let me run and see whether the output is right or wrong. I got the output as 2. Okay, let me give it as 6. So I need to get the output as 4. Okay, output is 4. Yes, 4. Okay, I got the output as 4. So let me submit and see whether test cases are fuzzy or not. See, 10 test case did not pass. The reason is that your output is right. You are getting correct output. But you need to return in terms of modulo 10 to the power of 9 plus 7. So you need to check that condition too. See, after here you need to do after adding area 5 minus 2 plus area 5 minus 3. I'm going to do modulo mod. So I declare it here int mod is equal to I'm going to typecast it. Okay. The reason is mod 1 e 9 plus 7. Okay, I'm typecasting to it and I'm going to return the value in terms of doing with model. Okay, let me submit it. Okay, the problem got executed successfully. The reason for doing here the dividing part is modulo into the around 9 plus 7 is see since your output is going to be very large, so this should be in the particular range of the data type int. So that's why we are going to dividing it with mod. Okay, so don't get confused it with. Sometimes you guys will get trying to do modular with area 5 minus 2 modular division with mod and you try to add it with area 5 minus 3 modular division with mod. So don't do like that. The reason is that when you're doing some certain expressions, so only you need to do modulo after this particular calculation or expression gets executed. So that's why I have put parentheses and I did modular division with mod. Okay. Okay. I'm going to show you guys what will happen if I try to solve this problem by using recurrence solution. Okay, let me try to solve it by using recurrence. Okay, let me create check whether if n is equal to 1. Sorry, n is equal to so let me say this condition can be same. So let me do anything. Okay, when is n is equal to 0, n is equal to 1, n is equal to 2, it's going to return it as 1. So no problem in that. Okay, but when n is greater than 3, you need to do Padovan sequence. You need to check for the nth Padovan sequence for its 2. In that case, I'm going to find out n minus 2 and I'm going to add Pado, pad, it's okay, it's Padovan. Oh, okay, let me copy this state and n minus 3. See, what's the reason for doing this is I'm going to recursively call the same function again and again. When I reach the nth value of 0, I will return 1 to the I will return 1 to the function. Okay. For example, if you see if you take the input as 6, so I try to draw here, it will be easy for you to understand. Okay. See, when n is equal to 6, it will move on to here. So 6 minus 2 is 4. Okay, 4. 6 minus 3 is 3. Okay, 3, no problem. So after this function will move on to the same parallel sequence. It move on to the same part here, and it will check whether n is equal to 0, n is equal to 1, n is equal to 2. No, here n value is 4. So it will move on to the parallel sequence of 4 minus 2 is 2. So it will, when 4 minus 2 is equal to 2, you need to return the value of 1. So that's why I have written here 1. So this value will be going stored in here. And when, if you see 4 minus 3 is equal to 1, in that case, I'm going to return the value of 1. So that will be stored here. So these two value will be get added and it will go and stored on Padovan sequence of 4. Okay. So value will be 2. If you see here, you are iterating for each and every time. For each and every value, you are iterating. So for if you see for n is equal to 6, no problem. You can see that this problem is okay. But if we take n is equal to 10, you are iterating for each and every time. So 10 means you are going to have go and check for 8, 6, 4, 2, 3, 1. You already checked for 3, but since you in fifth Padovan sequence, you need to recheck whether what is the value of 3. The same thing here, you already know the what's the value of 5, but when you're trying to find out the pattern sequence of 7, you need to check it for 5 as well as for 4. So this is not an right approach to solve this problem. You are checking again and again. So in that case, surely your time complexity will get exceeded. So that's why my problem did not solve right properly. So I tried to compile and see whether my problem is running or not. Okay, I got cannot find symbol. Add-ons, okay, S should be capital. So only reason is that this approach first I try to solve this by using recurrence, but for me only 10 test cases got passed. What is this pattern sequence? Okay, pattern sequence. Why it's not executing? Cannot find. Okay, okay, guys. I'll try to create a separate function. Like we keep it as PSV. 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 I'm going to create and function called PSV. I'm going to pass the integer in. So now I'm going to do the same part what I have did in my Padovan sequence. Just copy it and paste it here. Okay. Now I'm going to check which pen is equal to 0. Okay, these are no problem. And let me compile and see. See, for 6, no problem. It's working fine. If we take some big number like 19, so what's happening? Let me see. Yes, output is right. See, for one test, so one test cases, it's no problem. It will fine. It will work fine. But for when you are executing too many test cases, surely the problem not get executed fine. So time limit go exceeded. This why that's the reason you can't able to solve this problem by using recurrence. Maybe for me not executing or else I try to do modular division. So let me see what's happening. Let me submit and see. Same. No, it's not easy, executing properly. When 10 test cases got passed. So that's why I'm telling you guys recurrence solution is not that much a good approach to solve this problem. The reason is that you don't know you're trying to find out the same value again and again in each and every recurrence part. So that's why your problem is getting time limit exceeded. So always good to follow this tabulation approach. Single array tabulation approach will be a good approach to solve this problem. Okay. Let me see in our next video. Okay, bye.